Hi friends, in the previous lecture we discussed about some basic terms of nuclear chemistry in order to describe the nucleus of the particular atom, and in the previous lecture particularly we discussed about the two terms. One is atomic number and second one is mass number. So here atomic number simply indicates the number of protons present in the nucleus, while mass number indicates the total number of protons and neutrons present in the nucleus. So with this we are going to proceed for the next, that is representation of nucleus of any atom. So whenever you want to describe, whenever you want to represent the nucleus of any atom, then we are requiring the two terms. One is mass number, another one is the atomic number. So here this is way of representation of nucleus of any particular atom with mass number A and atomic number Z, while X is the nucleus of particular element. So this is the X. So this is the nucleus of particular atom. It is simply A is the mass number and the Z indicates the atomic number. So for that purpose we are going to talk about one example. Here this X, which is the nucleus of atom, and here we are going to take the one example of aluminium, or the nucleus of aluminium atom. So this aluminium having atomic number 13 and the mass number 27. So this 13 is the atomic number and this 27 is simply the mass number. So this 27, so simply this 27 indicates the total number of particles present in the nucleus, that we call it as the nucleons. So total number of particles means nucleons, means this is a total number of protons and neutrons present in the nucleus. So total number of protons and neutrons present in the nucleus of aluminium atom is 27, and total number of only proton present in the nucleus of aluminium atom is 13, and therefore the subtraction of these two, simply gives you the total number of neutrons. So here this is total number of proton and neutron, and this is total number of proton. So 27, that is A minus Z. So total number of neutron will be subtraction of this, and that is nothing but 14. So this is the number. So from this representation, from this way of representation with this example, we are able to calculate number of proton from the atomic number of proton and neutron from the mass number, and the only number of neutron can be calculated with the help of subtraction of this mass number and the atomic number. So here that's why 14 is the number of neutron present in the nucleus of aluminium, 13 is the number of proton present in the nucleus of aluminium, and 27 is the sum of these two. So this is a simple way to explain the representation of nucleus of any atom, from which we will get an idea, or we can calculate the number of proton and neutron present in the nucleus of any atom. So with this, till this we came to know that one important thing, that the two particles called as proton and neutron are present in the nucleus. Already in the start of this lecture, I told you the structure of any atom is made up of two parts. One is the central dense part, that we call it as nucleus, and another one is the outside nucleus called as the extranuclear region. And till this we came to know that the two particles are present in the nucleus. One is called as the proton, another one is called as the neutron, which are present in the nucleus and together called as the nucleon. The third type of the particle, which is present outside the nucleus in the extranuclear region, is called as the electron. So these are the three important particles of the atom, but proton and neutron are present in the nucleus together called as the nucleon, and electrons are present outside the nucleus. So here the weight or the mass of these all particles of the atom are always expressed in terms of atomic mass unit. So what is atomic mass unit? Atomic mass unit, it is 1/12 mass of carbon 12 atom. So what is the mass of carbon 12? So 1/12 of that mass is called as 1 atomic mass unit. So what are these particles? What are different types of the particles, and what is their mass in kilogram and mass atomic mass unit important? Okay. The first particle which is present outside the nucleus is called as electron, having mass of this 9.11 into 10 raised to minus 31, and in the atomic mass unit it is almost 5.4 into 10 raised to minus 14. That's why electron present outside the nuclear region is having very negligible mass as compared to electron. Definitely, if you see the mass of proton and the neutron, both are definitely having almost same mass in kilogram and atomic mass unit, that is 1.0073 and 1.0087 atomic mass unit. So this is nothing but the masses of. So how these particles are present in the nucleus. This is also one of the important, that is regarding the structure of atom, that we will discuss later. Just wait. Okay. So it is also observed that as the protons and the neutrons, these are present in the nucleus. But for example, we will take the one example of carbon 12. So carbon 12 has a mass, total mass, as 12 particles are present in the nucleus, proton and neutron. So expected, that is mass of carbon 12 is 12 atomic mass unit. So it contains, or the nucleus of carbon 12 contains 12 nucleons, means it contains total number of proton and the neutrons are 12. Out of these 12 nucleons, 6 are proton and the 6 are neutrons. But it is found that each nucleon has a mass is less than 1 atomic mass unit, because in the theoretical mass we discussed 1.00 something is the mass of each proton or the neutron. But actually it is found that each nucleon is having mass less than 1 atomic mass unit. Therefore, the mass of nucleus is slightly less than the expected mass. So this is the one thing. So this mass of nucleus is slightly less as compared to the mass of individual nucleon. Means the expected mass is to be greater, and the actual mass of the nucleus of atom is smaller. And this difference between the expected mass and the actual mass, this missing mass is termed as a mass defect. So this is one term that need to understand in order to explain the difference between the actual mass and the expected mass. So this difference is called as the mass defect. This mass defect indicated by means simply indicated by delta M. So delta M, so this mass nucleon and mass of nucleus. Mass of nucleons and mass of nucleus. Mass of nucleus, that is simply here is mass of nucleus. So this is nothing the expected. This is the expected and this is nothing actual. So this is, and the difference of these two is called as the mass defect. So how this mass defect can be calculated? How this mass defect can be calculated? So for that purpose, we are having this formula. Delta M is the mass defect. Z is, this atomic number. So it simply indicates the number of proton. So atomic number into mass of single proton plus mass of electron. Definitely this mass of electron is going to be very negligible whenever it is compared with the mass of proton, plus A minus Z. A is the mass number and this is the atomic number. So simply this A minus Z indicates the total number of neutron present in the nucleus of the atom. So total number of neutron into mass of single neutron minus mass of atom, expected mass. So this is, so here the meaning of this all term delta M is the mass defect, that is missing mass, difference between the actual mass and the expected mass of the nucleus of the atom. M suffix P, this is the mass of proton, which is having theoretical value 1.0072, 77 atomic mass, but actually it is less than 1. Whenever actually will measure, definitely will get the less than 1. While mass of neutron is expected 1.008665 atomic mass unit, while mass of electron is very negligible out of these two, that is 0.00548597, and this mass of nuclide in the sense mass, so this is nothing but the expected mass. So Z is the atomic number. Simply it indicates the number of proton, and A is the mass number. It means it indicates the number of nucleon, means number of proton and neutron present in the nucleus. So here I will talk about one example, that is, suppose we have asked here to calculate the mass defect of lithium having atomic number 7, and the mass of lithium is given, and the actual mass of this 7.016003. So this is the here this is the way. So here if you put all this value, this Z is the atomic number. So lithium 7, so mass number of lithium is 7, and atomic number you know very well, that is 3 is the atomic number. So here atomic number into mass of single proton, that is 1.007826, plus mass of electron. Already I told you this mass of electron is taken A here into consideration is negligible. So this value will be 0 here. That's why he has to neglect this. He has to neglect because this is very negligible. This is very negligible value as compared to the mass of proton and the mass of neutron. That's why he has to consider 0. Directly we will go for this A, that is mass number minus atomic number. So this into the mass of single neutron minus actual mass. This is not expected. This is actual mass given. So yeah, therefore difference after making the calculation of all this, we are getting the mass defect 0.0421335 atomic mass unit. So this is the way by which you will be able to calculate. So how many neutrons are present in the nucleus? This is also one of the important things, because this is one of the particles present in the nucleus. Then it is observed that the number of neutrons present in the nucleus of any atom can be variable. So number of neutrons can be different, but the number of proton present in the nucleus of particular atom always fixed. So this is, so range of neutron limited by degree of instability. So this is neutron number is responsible for the instability of the nucleus, and this is because of having very large number of neutron or very few number of neutron, and these are responsible for the instability of the nucleus of atom. And stable nuclei do not decay. So these are very stable, so definitely these are not undergoing decay spontaneously. But those nucleus which are having very high number of neutron or very small number of neutron, these are unstable nuclei. These are responsible for the instability, and these unstable nuclei of atom have certain probability to decay, leads to phenomenon called as radioactivity. So this is the important thing in order to discuss here. So here this unstable nuclei means having nucleus having very high number of neutron or very few number of neutron. These are responsible for the instability, and this instability leads to the phenomenon called as radioactivity. So these unstable nuclei have tendency to emit some radiation spontaneously, and that leads to decay of nucleus of atom, and this phenomenon is called as radioactivity. So in the next lecture we will discuss about the next concept, radioactivity, which is shown by unstable nuclei because of having very large number of neutron or very small number of neutrons. So this is nothing but the study of some basic terms of nuclear chemistry. Thank you. So in the next lecture we will resume in the next lecture with study of radioactivity. Thank you.